Thanks, Shahid. So today, I'd like to talk about what I see as the future of configuration. I think there's a narrative today that everything is worse than it used to be. The world is becoming a more difficult place. AI is going to start taking our jobs. There's a lot of concerns about the environment, everything from climate change to microplastics, and what are industrial manufacturing companies going to do about that. I think there's plenty of worries about the impact of social media. I think now that everybody is connected, it also means that misinformation can flourish and spread very quickly. And I think it seems to be the flip side of the connectedness that the internet had promised us. But I choose to be an optimist. I believe that the world is actually becoming a better place. I believe that AI is a tool that will help us become more productive. I think while there are many pitfalls to AI, I think the net effect is that AI is going to help us do the mundane jobs so that we can focus on the things that are important and the things that we as human beings can do better. I believe that there's another version, and that is that we are all becoming better citizens of the planet. I believe that there's a greater understanding amongst the general public about the impact of environmental choices that we make, and I think that we care more about those things, and we care more about the impact that we're having on the world today. And I think that to me can only be a good thing. I believe that while social media has a responsibility for some of the impact that it has, I also believe that in general, greater openness and greater connectedness creates a better experience for everybody. I think at a bigger level, and if you look over the course of history, connectedness and sharing of information and ideas has just improved innovation. So I think with all of these things combined, I think for manufacturing companies, you can see that there's a lot of these clear challenges that they need to address. And these are some of the things that I'd like to talk about today, and I'd like to talk about how Configit can help in some of these. So first of all, I'll be discussing some of the pitfalls around generative AI and what we can do about it. I'd like to talk about how we can help our customers make more intelligent choices when it comes to being more green. And I'd like to talk about openness and how Configit can leverage that. So over the last 2 years, generative AI has really seen some breakthroughs, and it's really come to the forefront of people's imaginations. And I think one of the most interesting parts about the recent developments is that people thought that AI was going to focus on the very, very mundane stuff, and that creativity would be one of the last frontiers that AI could actually tackle. But we can see, as for example right now, that it can really create some very impressive texts, images, videos, things that we really didn't think were possible. But I think the problem with this type of generative AI is that it cannot provide you with the truth. This is because it's based on probability and the data that it has been trained on. So AI will gladly generate this picture of the Pope wearing a puffer jacket if you ask it to, but it can't tell you whether or not the Pope has ever worn a puffer jacket. And if you ask it again, it might give you a different answer. So it'll give you a different answer each time you ask it. So how does this work? At a very high level, tools like ChatGPT use a technique called generative adversarial networks, or GANs, to generate their text and pictures. The overall idea is that there are two types of neural networks that are involved: the generator and the discriminator. In the first step, the discriminator is trained using a well-defined set of input data. Next, the generator creates some output starting from a completely random set of data. It then tries to fool the discriminator into thinking that it's a real image. The discriminator tries to determine whether or not the generated image is real or fake based on what it's been trained to do and based on a sample image. So if it's determined to be fake, this result gets sent back to both the generated image and the to the generator and the discriminator, and both of them begin to learn how to be better. And this competition goes on and on until the output data or the output image is good enough to get past the discriminator. And this is how things like ChatGPT can create these images. Now, the interesting thing about this, if you look at it, is that GANs can't invent something that is totally new. So you can only expect them to combine what they already know in new ways. So if you've ever tried ChatGPT, you'll probably notice it has a consistent style when it generates some of these images, right? But the variations of these images are good enough to fool most people. So I think we think it's creating something new, but in fact, it's just rehashing and repeating some of the stuff that it's been trained on. So why am I telling you all of this? And that's because if you look at this process, there's nothing about telling the truth in any of this. So one way to address this is to allow generative AI to do what it does best and try to use other techniques to compensate for it. So the human brain, if you look at that, is comprised of many, many different parts, all of which are highly specialized. So for example, there's parts of our brain which is responsible for what's called the autonomic system. And that is responsible for things like breathing and digestion. But there's other things that are like the prefrontal cortex, and that's responsible for controlling our impulses, for example. It ensures that we at least try to think about things twice before we say something that we're going to regret. So we can use this same approach when it comes to compensating for generative AI's lack of truth-telling. This approach is called the neurosymbolic approach, and it combines neural networks such as the ones that we saw before, together with a different type of AI called symbolic AI. Symbolic AI uses logic, rules, and semantics to create intelligent systems. One of the primary characteristics of symbolic AI is that it's very prescriptive, and prescriptive means that it needs to be done in such a way that all the rules are well described, but still it remains very, very flexible. So virtual tabulation, which is one of the core technologies which drives Configits products, is an example of symbolic AI. Now, by combining these two types of AIs, we take a best-of-breed approach. It's very similar to the concept of System 1 and System 2 thinking, if you've ever heard of that. System 1 is the automatic and intuitive and unconscious processes that we always go through, and System 2 is the rational and step-by-step process and is very, very explicit. So what does all this mean for configuration? So I think there's many manufacturing companies that are out there right now that would like to investigate what generative AI can do for them. But I think many people might be over-optimistic about what generative AI can actually do, at least what it can do today. And in my experience, you can use a lot of time and money on AI projects, but there needs to be a very, very targeted outcome, and it needs to match what the technology is actually very good at. So one of the biggest problems that we've seen our customers facing is when capturing the configuration possibilities of extremely complex products. So this ends up being very, very time consuming, and a lot of the data about these products already exists in the organizations. So it should just be a matter of gathering all that information and throwing it into a system. But it takes a lot longer and is more complex than that. So it can be tempting to throw generative AI at this problem. But we've also seen that generative AI has its own limitations, and we've seen that previously, right? First of all, it's trained on standard data sets and not your own. So if you use a foundational model, right, one of these basic models that is provided to you by big companies like OpenAI or Meta or Google to train with, you're basically at the mercy of the data that they've used. You're not guaranteed to have a consistent answer, right? So because of the randomness, because of the probability, this is not a thing that you want to have when you are modeling complex products. You do not want randomness. So we feel that using generative AI on its own is not the answer. We feel a better approach is to use a neurosymbolic AI approach to speed up this modeling process. And that's why at Configit, we're looking at this problem today. We've started a project that combines generative AI's capabilities to learn from large amounts of data, together with symbolic AI's ability to interpret complex rules and logic. So, our overall approach is going to be to use generative AI as a starting point for creating models, where we provide the generative AI with input about the details of certain product models. This includes all the data points and the rules that we'd like it to follow. The generative AI will output what's called LML, which is the domain-specific language that Configit uses to output, to model products. This LML will be passed to our compiler, which is going to validate that the combination of data and rules actually makes sense and can produce some of these valid combinations. The product modeler then can spend time testing the results and making sure that it actually matches the expectations of the business, right? Rather than using time on manual data entry. So the reason this approach is unique is because Configit is the only company that has a domain-specific language that is rich enough to capture all the product and model data. It's also a very flexible language, and that'll fit very well with the output the generative AI can produce. It means that there's freedom for the generative AI to produce output, but we can still guarantee that the structure actually makes sense. So we're going to be working on this concept quite intensively over the next year, right? And a special team will be focused on working with our customers to refine this solution. So we'll look forward to hearing more about this. Next, I'd like to talk about the challenges about being green. So in 2024, it's not easy being green. You would have thought it would be a lot easier. But especially as a consumer, I think many people would like to act differently when it comes to how we impact the environment. But I think one of the big problems that face most people is that there are just too many sources of information. It ends up being very difficult to understand how all this data fits together and how we actually should choose. And on top of that, there's also conflicting information which makes it difficult to understand what it is that we're actually talking about. Another element is the cost of being green. I think over the last 25 years, the cost of greener products has come down significantly, but they're still more expensive than products that leave a bigger environmental footprint. And until we reach a state where we truly can say that it's as cheap to be green, consumers need to be presented with good arguments as to why they should pay maybe a little bit extra in order to leave a smaller environmental footprint. And I think one of those arguments should be that the overall cost of operating a product is lower if you're more efficient. I don't think many consumers today have an easy way to calculate the total cost of ownership. For example, of choosing a product that might be a little bit more expensive to begin with, but is more energy efficient and cheaper in the long run. But overall, I think there's a shift in which parameters are going to be important, and it's no longer only the price in CPQ. When we look at some of the factors that come into play, to me this looks very much like what's called a multivariate optimization problem. This means we're trying to find the combination of factors that give us the best result, and in this case, the cheapest and the greenest. And of course, cheapest and greenest, they can have many meanings here. And actually, this is a similar problem to what happens when you're doing machine learning, when you're training some of these neural networks that we saw earlier on. I think one of the techniques that is often used to train neural networks is called gradient descent. Gradient descent is a method that tries to minimize the values in a multidimensional space. So the good thing about this is that in 2024, there's lots of libraries that are out there that will help you do these types of calculations. And there's also readily available infrastructure out there to help you run the calculations. So for example, cloud GPUs. GPUs are a great example of performing simple calculations very quickly, but doing them in parallel. And they're great for optimization problems like gradient descent. So because there's so much interest in machine learning and so much infrastructure out there, I think it's a great opportunity to piggyback on some of this stuff. So gradient descent isn't the only method for solving these types of problems, But a big reason is this ecosystem that has emerged and it has been built up around machine learning. And I think that just makes it a lot easier for us to get started. But one larger piece of this puzzle is the environmental impact data that needs to be a part of any of these equations. So historically, it's been very difficult to collect this, especially when there are so many parties involved. And there's so many different standards and so many ways of collecting this information. But I think that the interesting thing that's happening now is as a result of some of these increased legislation, there's a greater need for companies to provide this information, to collect this information. And the flip side of that is there's actually a lot of companies out there that are now providing software and services to help companies collect this type of information. And the great thing about this is that a lot of these companies are providing this data as a service. So it's a question of also just hooking into that kind of ecosystem. So at Configit, we're in the stages of investigating this approach and trying to create green configurations. We're establishing a project that's going to look into how to provide consumers with greater insight into the configuration choices that they make. The ideal outcome of this would be that we're able to recommend adjustments to chosen configurations and create the optimal balance of cost and greenness. So right now, we're interested in talking to partners that would like to explore some of these possibilities together with us. So for example, if you're already in the process of cataloging environmental impact data for other reporting purposes, it would be a great opportunity to use that data so that you can extend the choices of your own consumers. So if you're interested in participating in a pilot project together with us, then please reach out to me. Finally, I wanted to talk about openness and connectedness. I believe that in 2024, openness and connectedness are must-haves for any organization. So concepts like omni-channel, where a customer gets treated to the same kind of experience regardless of whether they are in a physical shop or buying online, or open source projects where you get inputs from all kinds of different people outside of your own organization, and open APIs that allow anyone to build on top of your core intellectual property. So I think these are all examples of how organizations have realized that working across boundaries is much more beneficial than keeping your data closed. So I think today, in 2024, it's just a natural way of working. But there's also a need to make sure that the core intellectual property that you have as an organization is secured. And for me, open source or open APIs don't mean that you need to give everything away. I think it's important that you're able to distinguish as an organization what is important and core to your business and where is it actually an advantage to collaborate with others. So I think the sharing of intellectual property, also together with suppliers, it's a fine balance, but I think it will make the entire ecosystem a lot more effective. So in order to make this a reality, architectures, data models, and deployments must all be more flexible and always live up to the contracts that they've made. Loose coupling of technologies ensures that you don't need to be in lockstep with your consumers, and it allows you to upgrade and optimize the way that you work. But this requires an active effort. That's why we're focusing much more on this topic in our upcoming A7 release. We're optimizing for the cloud. That means that we will be more secure and more efficient. Our cloud offering sits on top of Microsoft Azure, and we rely heavily on the security services that Azure has to offer. But beyond that, we're strengthening our authentication mechanisms to provide greater flexibility based on your preferred provider. It also means that we provide greater control over reporting about who has access to your ACE systems. We'll also work on improving the efficiency of ACE in A7, specifically focusing on the compilation of product models. And I think the goal here is to improve the overall experience for those that are creating product models. As a certified Microsoft independent software vendor, we are getting a lot of support from Microsoft these days, and a lot of support to help us get the most out of Azure. And I think that that's a very positive partnership. We're creating 2 cloud native services, as Henrik mentioned earlier today. the ACE thread, and the ACE configurator. We're building these components from the ground up to be cloud native, and that means we're focusing a lot on how we can ensure that we can deploy these changes quickly and get functionality into the hands of our customers a lot quicker. Finally, we're strengthening our approach to open APIs. One of the unique features of our technology is that we're so flexible that you can model basically anything. It allows our APIs to be truly open. It means that we don't need to worry about what comes in because we know that our fundamental technology will take care of making sure that everything is valid. It's a perfect way, for example, to share information between you and your suppliers, since no intellectual property actually gets shared between you. So, just to wrap it up, the intelligent future that we see is one where where AI helps us become a lot more productive, where consumers are able to make intelligent choices that support our environment, and where openness and collaboration provide a better experience for everybody. So that's all I had for today. Back to you, Shahid.